4 point charges 2, 5, 2, minus 5 are located at the corners of a square of side 10 centimeter. What is the force on the charge? 1 microcoulomb placed at the center of the square. Done. So let us find electric field. After that, force. What is the force? Using forces, you can find force. Or else, using electric field, you can find force. So first calculate electric field and then find force. So both the methods are correct. 4 point charges are located at the corners of a square. What is the force on this charge placed at the center of the square? Fine. So this can be solved using two methods. Find out F1, F2, F3, F4 and find the resultant force. Or else find electric field due to charges E1, E2, E3, E4. Find the resultant field. Then force equal to charge into electric field. Okay. So both the methods are correct. By solving this problem by any of these two methods, you will get 5 marks. Don't worry about that. So let me use electric field and thereby force. Now, electric field is given by 1 by 4 pi epsilon naught Q by R square. Now the diagram. Students, use scale pencil. Draw neatly. This is A, B, C, D. At A, 2 microcoulomb. 2 microcoulomb. B, 5 microcoulomb. C, 2 microcoulomb. D, minus 5 microcoulomb. After that, we have to find resultant field at the center. This is the center, O. So to find electric field at O, we need these distances. Length of each side is 10 centimeter. This is 10. This is 10. Therefore, we want AO, BO, CO and DO. In one step, let us find that. Okay. So AC equal to root of AD square plus DC square. AD square plus DC square, which is equal to root of 10 square plus 10 square. AO is AD by 2, AC by 2. This is AC. AC by 2. 10 root 2 by 2 is 5 root 2 centimeter. So we have all the distances. Next, electric field at this point. Electric field at this point due to this. Since it is positive charge, away. EA. Electric field at O due to charge at A. Due to charge at A. Denoted by EA. Constant is 9 10 to the power of 9. Students, please copy. Charge is 2 micro minus 6 by distance. Distance is this distance. 5 root 2 centi square. Root 2 square is 2. This get cancels with this. 9. 5 square is 25. 9 by 25. 9 by 25. 0.36. 10 to the power of 9 minus 6 is 3. Minus 2 is minus 4. This goes to numerator 7. 10 to the power of 7 Newton per coulomb. This is EA. What's the direction of EA? Along OC. Now let us find electric field due to B at this point. Electric field at O due to 5 microcoulomb. Electric field due to charge at B, EB, 9 10 to the power of 9. Charge is 5 micro minus 6 by distance is again 5 root 2. 5 root 2 10 to the power of minus 2 square. Five square 25, 1 5, root 2 square is 2, 9 by 5 by 2. It should be, where should I write? 9 by 2 root 2 square and then one more 5. 5 to 10. So it is 9. 0.9 10 to the power of plus 7 Newton per coulomb. What's the direction of this? This is along, this is positive charge. So along BO. Along BO. Now, electric field at this point due to this charge. Electric field at O due to charge at C. EC equal to 9 10 to the power of 9. Charge is 2 micro minus 6 by distance is same distance 5 root 2 centi square. See, this is same as this. So EC equal to 0.36 10 to the power of 7 Newton per coulomb. Since this is positive charge, electric field is away. So this is electric field due to charge at C. Along CB or sorry CO or CA or OA. Along CA. Now electric field at this point due to minus 5. Due to minus 5, take care of this negative sign. So this is the electric field E due to D. This one is electric field due to B. So electric field at O due to minus 5 microcoulomb E due to D equal to 9 10 to the power of 9. Charge is negative sign, consider only magnitude 5 10 to the power of minus 6 by distance. Distance is again 5 root 2 10 to the power of minus 2 square. This is same as this 0.9 10 to the power of 7 Newton per coulomb. Direction of ED is along OD or BD. Along BD. Now we have all the electric fields. These two are equal and opposite, therefore they get cancelled. These two are in the same direction, therefore they are added. So next step, let us show that these two get cancels. Resultant of EA and EC. These two are equal and opposite. E dash equal to EA minus EC. Why minus? They are in different, opposite directions. Magnitude of EA is 0.36 10 to the power of 7, one finger space minus one finger space 0.36 10 to the power of 7. Write neatly, okay? This minus this, 0. So resultant of these two is 0. Now resultant of these two. Resultant of EB and ED. EB and ED. So E double dash equal to EB plus ED. Students, why it is EB plus ED? They are in the same direction. And EB is 0.9 10 to the power of 7 plus 0.9 10 to the power of 7. This is 1.8 10 to the power of 7 Newton per coulomb, and this E double dash is the resultant electric field, and direction of this electric field is along OD. So we found out the resultant electric field, but we have to find force. Therefore, force, electric field, relation between force and electric field is F equal to Q into E. So force F equal to Q into resultant electric field. Charge is, where is that charge? Here is the charge, 1 microcoulomb. 1 micro. What is the force on a charge? 1 micro. Electric field is 1.6, 1.8 10 to the power of 7. That is micro. This is micro. 10 to the power of minus 6. Electric field is 1.8 10 to the power of plus 7. 7 minus 6 is 1. Give 1 to this. 18 Newton. This is the force along the same direction, because it is a positive charge in the same direction, along BD, along BO, along BD, along OD. You can write anything, okay? So students, take care of the diagram, take care of E1, E2 or EA, EB with proper unit. After that, the resultant. You can also solve this using forces. Two charged spheres A and B have their centers separated by 50 centimeter in air. What's the mutual force of electrostatic repulsion if charge on each sphere is this? The radii of two spheres are negligible when compared to distance. Also calculate force of repulsion if charge on each sphere is doubled and distance between them is halved. So it is force. Write the formula for force. Force F equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Okay. Q1 Q2 by R square. So because of these two charges separated by 0.5 meter. So this is a small diagram. Q1, Q2, distance is 50 centimeter, 0.5 meter. This charge equal to this charge, identical charges, 6.5. Therefore, force equal to, constant is 9 10 to the power of 9, charges 6.5 10 to the power of minus 7 into 6.5 10 to the power of minus 7 by distance square, 0.5 square. 0.5 square. Take care of centimeter, okay? And then this square. Use calculator, students. 9 into 6.5 into 6.5 equals, then divided by 0.5 square is 0.25, divided by 0.25 equals, find that number. It is 1521 10 to the power of minus 7 minus 7 minus 14, 9 minus 14 is minus 5. Now here is decimal point. 1, 2, 3. So if I shift it here and make it 1.521 10 to the power of 3, 10 to the power of 3, 10 to the power of minus 5 is 10 to the power of minus 2. Force is Newton. This is force. Since they are identical, repulsion. There is repulsion. Okay. Now calculate force if charge on either sphere is doubled. Fine. F dash equal to 1 by 4 pi epsilon naught. This is 2 times q, first charge, second charge 2 times q by distance between them is halved. So it is r by 2. R by 2 square. R by 2 square. Now 2 square 4. That 4 goes to numerator. 2 into 2 into 4. 16. So it is 16 times constant q by r square. This is 1 by 4 pi epsilon naught. Done. You can also write k. 16 times. We have calculated this. 1.52 10 to the power of minus 2 equal to 24.3 into 10 to the power of minus 2 Newton repulsion. Again F dash. Repulsion. So it's a pretty easy question or easy problem. 2-point charges 4, 1 are separated by 30 centimeter. Find the position between them at which resultant electric field is 0. This is 0. Fine. Force is 0. Resultant electric field is 0. So electric field expression constant 1 by 4 pi epsilon naught q by r square. Students, just by looking at the problem, identify the quantity and corresponding to that write the equation. Okay, don't forget. So this is the electric field. These two are the charges. One is 4 microcoulomb, second is 1 microcoulomb plus they are separated by 0.3 meter or 30 centimeter. See, in such type of problem, let this be in centimeter. Okay, of course you can convert this into meter and solve. Let this be in centimeter. You will understand why. Because centimeter or meter doesn't matter. Let this be the point P at a distance say x, where the electric field is 0. So remaining distance is 30 minus x. 30 minus x. Because of positive charge plus 4, electric field is away. So this is E1. Because of this charge, if it is away and equal to E2, equal and opposite, then the resultant field is 0. So magnitude of this should be equal to magnitude of this. So magnitude of E1 should be equal to magnitude of E2. If somebody writes like this, that is also fine, because without arrow mark it is a magnitude and this is also a magnitude, or else write like this. Okay, and electric field is constant charge 4 nano 10 to the power of minus 9 by distance is x square equal to the other charge is nano by distance is 30 minus x, its square. Now k get cancels, 10 to the power of minus 9 get cancels, there is square, so take square root, so square root of 4 becomes 2 by x equal to, this is 1 by 30 minus x. Now simplify, 2 into this, 2 into 30, 60 minus 2x equal to x. This goes to other side, then x equal to 60 by 3. 60 by 3 is 20. This is 20 centimeter from the smaller charge, no, from the 4 microcoulomb. X is from the 4 microcoulomb. Therefore, x equal to 20 centimeter from 4 microcoulomb. 2-point charges 2 milli, 4 milli are placed at A, B respectively of right angled triangle ABC. Construct a diagram. Be careful with ABC and the angle. B is 90 degree. So B is at 90 degree. Calculate magnetic field at B. So we have to find at B. Resultant field. So electric field. Electric field equal to 1 by 4 pi epsilon naught Q by R square. We have the expression. Now right angle triangle diagram. Scale, pencil, eraser, draw neatly. Okay. Let this be the right angle triangle. So this is B. This is A. C. A charge is 2 millicoulomb. 2 millicoulomb. C charge is 4 millicoulomb. 4 millicoulomb. Done. After that, AB. AB is 3 centimeter. AB is 3 centimeter. BC. BC is 2 centimeter. Calculate resultant magnetic field at B. So because of this positive charge, electric field is away. So this is E1. Okay. E1. So because of this positive charge, electric field is E2. So resultant of these two means complete the parallelogram. Draw the diagonal. This diagonal represents the resultant. Students, write using scale pencil. Okay, don't forget. This is E. So first step, find E1, E2. Second step, find the resultant. Now, electric field at B due to first charge 2 millicoulomb. 2 millicoulomb denoted by E1 equal to constant is 9 10 to the power of 9. Constant, this constant. Charge is 2 millicoulomb. 2 milli minus 3 divided by distance. Distance is 3 centi minus 2 square. 3 square 9. 9 get cancels. 2 9 minus 3 minus 2 into 2 is minus 4 minus 3 is minus 1 goes to numerator plus 1 10 to the power of 10 Newton per Coulomb. And what's the direction of E1? E1 is along AB. Along AB. Now E2. Electric field at B due to second charge is 4 millicoulomb. E2 equal to 9 10 to the power of 9. Charge is 4 milli minus 3 by distance is, this distance is 2 centi square. So E2 equal to 2 square 4 gone, 9 10 to the power of, so all other powers are similar to this, same as this, therefore 10 to the power of 10 10 to the power of 10 Newton per Coulomb along CB. Now resultant of E1 E2, angle between them is 90. Okay, so resultant of E1 and E2, E equal to root of general expression E1 square plus E2 square plus 2 E1 E2 cos theta. Theta is angle between the vectors. Sorry, theta is theta is angle between the vectors E1 E2 is 90. Therefore, we can simply drop this term. Root of E1 is 2 10 to the power of 10, 2 10 to the power of 10 square plus 9 10 to the power of 10, 9 10 to the power of 10 square equal to 10 to the power of 10 common factor. Remaining is, students observe, 10 to the power of 10, 10 to the power of 10, take that outside, 2 square 4, 3 square 9 square 81, 4 plus 81 85, root 85 10 to the power of 10, which is equal to root 85 9.22 10 to the power of 10 Newton per Coulomb. This gives magnitude. Okay, observe the question, calculate magnitude of the resultant. Only magnitude is sufficient. Magnitude. If they mention calculate the electric field, resultant electric field, then you should find direction also. So here it is not asked, so this is sufficient. Why it is asked, why it is not asked means this is sufficient for 5 marks. See, diagram, formula 1 mark, diagram 1 mark, 2 marks, 3, 4 and resultant 5. So this is called scheme of evaluation. If you skip any of these steps, remember you have lost that mark. So please make sure that you write neatly. Okay. Copy the solution, practice.